In this video, we're going to talk about how to compute the derivative of a linear function. And, and now that we've talked about the definition of the derivative, then we're going to start moving towards computing the derivative not through the definition with the limit definition, the limit as h goes to 0 of that expression, but rather what we're going to do is start developing some rules that allow us to compute the derivative more efficiently. So even though we're going to use the definition here, this is probably the last time at this point in the course where we'll start using this, where we'll use the limit definition. Okay, so there's the limit definition that I'm talking about, the limit as h goes to 0 of f of x plus h minus f of x over h, and we are going to use that to compute the derivative of this linear function. So remember, the graph of a linear function is a straight line, and n is the slope of the line, and then b is the y-intercept of the line. So you might recognize this as slope-intercept form from your algebra classes. Okay, so we are going to apply the definition to this. So f of x plus h, that's what we would get when we plug x plus h in for x. So we would get m times x plus h plus b. And then minus, that's this minus here. And then f of x, right here, f of x is just a linear function, mx plus b. Okay, so that's the form that the limit would take. And there's a lot of simplifying that we can do on the top part of this fraction. And so first off, we can distribute the m through there and get mx plus mh plus b, and then distribute the negative sign through the parentheses. Then, of course, we have some like terms in there, the mx and minus mx, and then we have b and minus b. So on the top, everything but mh drops out. And then, of course, we have some common factors between the top and bottom of the fraction, so we can cancel out those common factors. And then finally, we have the limit as h goes to 0 of the function m, right? Well, there is no h in which to put this 0, and so therefore this is a constant function, and the limit of that constant function is just the constant. So this limit turns out to be m, right? So the derivative of a linear function is m, and remember, m in terms of a linear function is the slope of the line. So in the case of a linear function, the derivative is just the slope of the line. It's just a constant m. Okay, so there's recapping here. If I have a linear function, f of x equals mx plus b, right, then the slope of, or the derivative is just the slope, m. So there's two particular situations that I want to apply that to. First off is the function f of x equals x, right? So this would be a linear function where the slope is 1 and the y-intercept is 0, okay? And so just applying this definition, the derivative would be the slope of this line, which has slope 1. So the derivative of the function f of x equals x is just 1. All right, and then the second case is where the m is 0. This would be the graph of a horizontal line, okay? So if f of x equals just a number, b, right, the y-intercept, then the derivative would be equal to 0, okay? So if I have a line, the derivative of the line is just the slope of the line. It's a number, right, every single time. In particular, if I have the function f of x equals x, its derivative is equal to 1. And then if I have f of x equals to some number, a constant, then the derivative is just 0.